all rules. Now during our days when I was small, when I was in college, so we used to use such a drawing board to make the drawings. We used to stand and we used to make the drawings. Our engineering drawing paper used to be of about 4 hours. We used to use the mini drafter to make the parallel lines, in various angles, to make projection lines and so on. You can also see the T bar. The T bar, you also use this T bar a lot in Tata Motors to do quick check of 90-degree, and also to measure the dimensions of certain components. So like that, we can also see, go to next slide and see these things that you will be ideally be have seen these things in your compass box during your school days. These are set squares where you can get the quick angles of 30, 60 and 45-degree. You can see the compass is having used to make a circle. You can see the divider, you can see the projector, French curves. French curves are now not that actively used, but they used to be used sometimes by in olden days to join three or more points, such that all the 3 or 4 points will lie on a single line. So like that the French curves were used. In pencils, you can see HB pencil, F, H, 2F, like that. Different types of pencils have different shades. HB pencils is generally used to make the main components in dark shape. Similarly, 2H pencil is used to prepare a drawing, especially projection lines in light shade. And HB pencil, as you can see, it is very dark. But 2H pencil, even if you press such a pencil harder on the page, it will still draw a very light drawing on the engineering drawing page. So like that, different type of pencils are also used in engineering drawing. You can see the description, same description is there. Divider, you can see it can be used to transfer the dimensions from one particular part of the drawing to another. So like that, all these things are very basic. Now mostly, instead of using these things, we are making the drawings on various softwares like AutoCAD, Solid Edge, ZWCAD, Creo, and so on. Like that, there are many 2D, 3D CAD software. SolidWorks is also very famous one. So like that, there are many such softwares that are now used to make the 2D and 3D drawings. We generally don't use the pencil and page to make the drawings now. All the drawings have been digitalized by many companies. Even the old drawings have been digitalized now. So on. Let's go ahead. Now here we can see various sizes of sheet are there. Mostly for engineering drawing, we will use A0, A1, A2, A3 size pages. You can use one A0 page, and you can using that A0 page, you can make various different sizes of the paper from the A0 size page, like A1, A2, A3, A4, A5, A6, A7, A8 and so on. Generally, A4 size page you must have seen of long books that we use in the our day-to-day life while taking printout or photocopy. So like that, you can see the sizes standard ISO A series online. You can see the dimensions of these pages. No one will ask this in the exam, but this is the basic information that you should know. And you can also see the various what is the aspect ratio between the two sizes of the two different sheets. they are correlated to each other. So that aspect ratio you can see 1 is to square root of 2. No one will ask this in any exam, but you should know as an engineering drawing expert. Next sheet, what here we can see is basically how dimensions are denoted in an engineering drawing. You can see, let's assume this is a sheet cut over here. Now this sheet that is cut over here, you can see the dimensions of that sheet that are shown in just besides the sheet. Now here you can see there is a dimension shown here. This is the way how you denote a dimension with arrows on both sides. The line that shows the length of that shape of that object, so that line should ideally not touch directly to the main object drawn. Also it should be made of a light color. Why? So that we can distinguish between the real object and the lines drawn for showing the dimensions only. So you can leave a slight gap over here and make the rest of the line, and you can make this a dimension line. You can see on the top it is written dimension line. You can denote the dimension, how much centimeter the is the length of that dimension. Here it is 15.25 plus minus 0.032 and plus 0.032 and minus 0.01 is the tolerance. We will go in depth afterwards on this tolerance separately. You can see the arrowheads made for making the dimension line. Also, this is the extension line. No one will ask this in exam, but you should follow these basic rules to make a dimension line, and so you should know these things. This is the leader line. Basically, this leader line will show the dimension of that object. Let's say there is a small circular hole or a cut inside that metal sheet. Now that to show the diameter of that particular circle, we use the leader line that will point towards that particular part of that object. Here the diameter is 1.75, and that diameter is in two places because there are two circular cuts that are made over here, and you can see a diameter symbol written just before the 1.75 dimension. So this one this symbol you need to learn, and it will be very used again and again in all the drawings, most of the drawings. Also you need to remember the R 2.55, that is the R is the radius over here of this cut, circular cut. So you need to remember the R and the diameter symbol. It will be very useful. Then you can also see 4.25 over written over here. It is written inside a box. 4.25 is written in a box. What basically this denotes is that 4.2, whenever you are starting to make a cut or check the dimensions etc. by inspection department or quality control department and so on, you need to start checking the dimension from this side, 4.25, and then we will check the other dimension. Let's say 15.25. If this 15.25 is within the tolerance limit of plus 0.032 and minus 0.01, does this lie in the this limit? We will check this part. We will check the radius 2.55 if it is in the if it is the same or not. We will check the diameter 1.75 at two different places and so on. But at the end we will check the dimension of 1.7, which is in the curve bracket. So basically whatever is written in the box is basically the dimension that we need to measure or check in the beginning, and the dimension that is inside a curve bracket, that will be checked or made at the end. Okay, so that's it in this particular slide. We will move to the next slide. your dimensions should be, there are different ways of denoting the dimension. It can be linear dimension, angular dimension, size dimension, aligned and aligned and unidirectional dimension. So in this dimension, linear dimension is basically same like this one. uh, Linear dimension basically is same like